substitution here that's a little annoying. So you have 2 times 0 to infinity of what? X squared 9 plus what? Dx. Okay, hold on. So you said u is equal to what? What'd you say u equals?
U equals,
Yeah. X to the third? X to the third, so du is equal to 3x squared dx, so dx is equal to du over 3x squared. So we end up with, well, we know it's going to be, we can keep working on this, can't we? 2 times 0 to infinity of what? We've got x squared over 9 plus u squared du over 3x squared. That's correct. Something nice happens here. Yep. That goes away. And you're left with 2/3. Oh, there's a 3 right there, I see. So you end up with 2 over 3 times the integral of 0 to infinity of what? 9 plus u squared du. Now here's the thing. There's two things I want to ask. You want it u equals what? Don't do that. Don't do that. This right here is really, really close to being what you want it to be. It's really close. What is it really close to? No, not arctan. It's really close to the derivative of arctan, what I just circled there, right? We're really close to it, but it's not quite there yet. So how do we do it? What can we do to make it look like arctan? There's a substitution, Tina, that we can do. Yeah, open Notepad. Yeah, there's your solution, right? Yeah. U equals what? Yeah, how about 3v? Right. And actually, you know what? V is what you usually use next, but it's dangerous because what do my U's look like? V's. What do my V's look like? How about we just do P instead? So how about du is equal to 3 what? dp, so dp is equal to du over 3. Okay, that's nice. So now we have 2/3 times the integral of 1 over 9 plus, we plug in, and what do we plug in? 3p for u, so we end up with what? P squared, and then we end up with du over 3. So if we do this out, we end up with 2 over 9. I'm taking that out. 1 over 9 times 1 plus p squared should be a d. dp, sorry. And hold on a sec. So what should it be? You substitute it in there. This is that's not erasing. That's really annoying. Yeah, which kills the other 3, right? So that 3 kills that 3 right there. And then what can you factor out? 2 over 9 times the integral of 1 over 1 plus dp, which is equal to what? 2/9 of tan inverse of p plus, but what does p equal? u over 3, right? So you end up with 2/9 of tan inverse of u over 3, right? Plus c. What does u equal? X cubed. So you end up with 2/9 tan inverse of x cubed over plus c. So not quite done yet. There's your indefinite integral, right? Now we're doing the limit as, what was it? To infinity, right? No, it's t, as t goes to infinity of the integral of 0 to, of 2/9 of x cubed over plus c.
Oh, wait, no.
Oh, not plus c. It's not the integral. It's just it's evaluated. Excuse me. This, yes, I understand. Ready? Let's do one step and then do 3 others, okay? We're evaluating it from what to what? 0 to t, and we're doing the limit of this thing right here, right? Thank you. That's what you were telling you forgot last night. Let's make sure we do it this time, right? Exactly. So what do we end up with? We can factor out the 2/9. You're absolutely correct. So it's 2/9 times the limit as t goes to infinity. And we have to actually, in a second, of what? Of tan inverse of t cubed over 3 minus tan inverse of 0. Oh, let's make it 0 over 3 like this. What's tan of 0? What's tan inverse of 0? 0. That actually works nicely. What's tan inverse of a bajillion? Remember we did this yesterday? No, not 1. what is it? Pi over 2. Remember, it's the sideways S curve. It's pi over 2. So you end up with 2/9 of, I keep on hitting that, I'm sorry, of what? Of pi over 2. Well, I'll make it at time minus 0. So you end up with what? Pi over 9. No, the 2's cancel, so you have pi over 9. So we know that that's u times v, and that's du. So you end up with negative ln x over x. Then you with plus, right? X to the negative 2 dx. Can we integrate this thing? Yep, negative ln x over x minus what? Minus 1 over x. And what are we? Not really, yeah. From what to what? So 1 to t? 1 to t. And we're doing the limit as t goes to infinity. Yay, excitement, she wrote. Okay. So we end up with negative ln t over t minus 1 over t minus negative ln of 1 over 1 minus 1 over 1. And this is the limit as t goes to infinity. So what happens here? What does this go to? And what does this go to? It does go to 0. This is what? So you end up with plus 1, which means it's convergent. That's a fun one. Good. We're scared of the simple ones, right, kids? We're scared of the simple ones. So how about if I ask you something about this? 0 to 3 of dx over 1 minus x. What's the problem? There's an asymptote, yes. There's an asymptote that causes a problem. That is correct. Indeed. So the challenge here is that theoretically, could you come up with some sort of guess, or you could do the antiderivative and then use the fundamental theorem. You could try using the fundamental theorem of calculus part 2, but the problem is that if you use the fundamental theorem of calculus part 2 going from 0 to 3, what happens between 0 and 3? There's a discontinuity. You can't plug in 1, right? There's an infinity problem here, right? So sometimes if you try to just directly integrate across it, you'll get an answer like 7, and that is totally wrong. It's just not going to work. So my question to you is, how do you think we're going to test to see if this is a convergent or divergent? What do you think we're going to do, Thomas?
Use our calculator.
Okay. No. What do you think we're going to do, kids? We're going to split it up. So let's just look at this. We're going to go from 0 to, okay, this looks like an idea, 0 to 1 of 1 minus x, and what are we going to add to it? 1, 2 of dx over 1 minus x. Now we still can't really evaluate at 1 though, right? It's a problem. So for what's our tactic been? Instead of evaluating at 1, what are we taking? T. So you're doing the limit as t goes to 1 from the right or from the left this time? What do you think? From the left. From the left of 0 to t of dx over 1 minus x, and then you're doing plus the limit as t goes to 1 from the right of t to dx over 1 minus x. Try doing that right now. See what happens. The integral of the first one here, you have to evaluate from 0 to t. So what's this one? It's going to be ln of what? Well, you don't have to. Do you have to do the absolute value this time? You do? Okay.
Well, not in the first one. In the second one.
Not in the first one. Okay, so ln of 1 minus, like this, from what to what? 0 to t. So you end up with ln of 1 minus t minus ln of 1, which is nicely 0. And then what are you adding to this? Well, it's going to be ln of, what is it? The absolute value, yep. From t to 3. So what do you end up getting? Plus ln of 2 minus ln of what? The absolute value of, oh wow, that disappeared. 1 minus t. And you're doing this right here, the limit as, oh, this one right here is t to 1 from the left. And what's this one right here? T from the right. Limit is 1 minus. Thank you very much. That would change it completely.
Yeah, it's perfectly possible now.
Yeah, no kidding.
Well, the second one.
t to 1 from the right. Okay. Hold on. Let's see what happens here, okay? Let's see what happens. I'll keep this on. What is this getting infinitely close to right here? What is that getting closer to? 0 from the right. So what is this, right? Well, we know that this goes to, that is 0, right? So what does ln of 0 from the right equal? Negative what? Negative what? Negative infinity, right? And then what are you adding to it? Well, you have ln2 doesn't change, right? Minus ln of, it's going to be a little tiny positive number, right? So what is this going to be? Minus ln of, well, yeah, you have to be careful here. So what does this go to right here? Well, excuse me, just that right there. Just that right there goes to, well, 0 from the left and its absolute value of it, so it's 0 from the right. And you are so ln of 0 from the right is negative what? Negative infinity, like this. So I see what you're saying. I totally see what you're saying. You have this, negative infinity plus ln2 plus what? Plus infinity. So it looks like this should be ln2. Does that look like it's true?
No.
Yeah, you have to be really careful here. One thing you have to be very, very careful about is, do these infinities, in fact, cancel? We want them to, right? Because we think of infinity as being kind of immutable, like you're getting infinitely big, you're getting infinitely big. The challenge here is, are they? The last one is this. Oh, you want me to say that again? Yeah, okay, well here's this. This is the last topic here. It's what I've already mentioned. If that's f of x, and this right here is g of x, and we say that g of x is going to be always less than f of x, if, what do you think I'm going to say, everybody? If the integral from a to b of f of x dx is divergent, what do you know? A to b of g of x dx is divergent.
How is it divergent?
No, the convergent. Why am I writing this? Oh gosh, I'm sorry. Convergent. And you were right when you said it may be.
Yes. Might be divergent.
Sorry, I don't know why I wrote that. Been a little scrambled. The idea is if one function is less than another and the bigger one converges, then the smaller one must converge. Now, can you see, I drew this picture very intentionally. I drew this picture intentionally to give you a hint as to, did I say you could eat those? Okay, just checking. Yeah, I've been throwing away all the excess information. You guys are going to convince me of a lot of crazy stuff right now. Here's the deal. If you had to characterize the two functions there, f of x and g of x, what would you say about g of x compared to f of x? Besides that it's always less than.
It's more bumpy.
It's more bumpy, right. So the point is, you can have a function that's smaller than another, but then acts really, really, really crazy, right?
Yeah.
And it might be very, very hard for you to algebraically manipulate it. So what do? You find something that's bigger than it, and then show that that roof is convergent. Because if the roof is convergent, then you're good. You don't need to do all the nasty stuff.
What I was trying to prove was yesterday with the.
This one?
Oh wait, can you also do?
How about this one right here? Yeah, what do you want, Andrew?
Also, if g of x is divergent, then f of x is divergent.
Correct. If the absolute converse, sure, absolutely. 1 plus e to the negative x over x dx.